Okay, so on number 3 here, we want to simplify this expression and define where the variables are, or where the denominator is equal to 0, so where the function is undefined. So the first thing we've got to do is factor. So that was, for some of you, is probably the hardest part of this, is just doing the factor in itself. So, in the numerator, so I've got to get the factors of 6 and 5, that when I multiply them and add them together, I get 13. Okay? So in this case, because the 5 is negative, that means that my signs here are going to have to be the opposite. So I'm really going to be doing some subtraction with it. So how do you want me to do it for you? Do you want me to do slide and divide, box method? Okay, the slide and divide, okay? All right, so with the slide and divide then, first thing we're doing is our first step, is we're going to multiply a times c. So we're multiplying 6 times 5. So we get x squared plus 13x minus 30. So what are the factors of negative 30 that add up to 13? Okay, 15 and 2. So it's going to be positive 15 and negative 2. So our second step for slide and divide is to factor it. 15 times negative 2 is negative 30, and 15 minus 2 is 13. Okay, all right. Now our step 3 is, we're going to divide by a, so we need to divide 15 and 2 by 6. All right, the value of a. So we simplify that. We get x plus 5 halves and x minus 1/3. Now the nice thing about this is when we do the denominator is that this part right here is going to tell me where the zeros are for the denominator, so it tells me where it's undefined. But now my last step then, I need to move the denominators in front of the x. Right? So we get 2x plus 5 and 3x minus 1 would be my factorization for the numerator. Oh, I missed that 6. All right, so there was the numerator. We need to do the same thing with the denominator then. All right, so I'll use blue for that one. All right, so we're going to start out same thing. We multiply a times c. 6 times 7 is 42. All right, so step 1, we get x squared minus 23x plus 42. Then we're going to factor. What are the factors of 42 that add up to negative 23? Okay, 21 and 2, right? 21 times 2 is 42. 21 plus 2 is 23. So we get x minus 21. Oops. And x minus 2. Okay. Step 3, divide by a again. So we're going to divide by 6 for both of them. Then we simplify it. So we get x minus 7 halves and x minus 1/3. And then the last step is to move the denominators. So we get 2x minus 7 and 3x minus 1. Right, so we have like factors in the numerator and the denominator, so 3x minus 1, those will cancel. So my answer is 2x plus 5 over 2x minus 7. Now, they want us to tell it where it's undefined. Okay, it's undefined where the denominator is equal to 0. And when we figure that out, we go back to the beginning, but we can do it in the second spot where it's already been factored. Okay? And the reason I like to slide and divide is because now when I look over here at this part, it tells me where the denominator is equal to 0 because that's where I show my factorization. So it's equal to 0 at positive 7/2 and positive 1/3. So that means that x cannot equal 7/2 or 1/3, where the denominator would be equal to 0. All right, so that one is kind of a tough question because of the factoring is a little bit tougher. Okay, but if you use that slide and divide method, it should work out real well for you. Right. Doing number 4, I'm going to try and cheat a little bit because I'm going to assume right at the moment, because there's only x plus 4 in the numerator, I'm going to assume that x plus 4 is a 0 for the denominator also. Okay, and we'll see if it works. So we get x plus 4 in the numerator. Now, if I'm assuming that x plus 4 is a factor of the denominator, then what's the other factor? And here's how I decide this, okay? When I multiply these two here, the first terms together, what should I get? If I multiply x times whatever goes in this spot here, what should they give me? They should give me 3x squared. They should give me this first term here. Okay? So what do I multiply x by to get 3x squared? 3x. Okay? So 3x will go here. All right? And then if I multiply these two together, what should I get? Negative 4. So 4 times what is negative 4? Okay, negative 1. So let's check it and see if it works. Okay. So I know that my first term and my last term are correct. The question is the middle term correct? So I'm going to check these two parts here. All right. 4 times 3x is 12x, right? And x times negative 1 is negative 1. So 12 minus 1 is 11. Okay, so I factored it correctly then because it gives me the right middle term. But that just is one way that you can divide those that are a little bit harder. Okay, or factor them. So we can cancel out the x plus 4s. Don't forget there's a 1 in each of those spots. So we get this equals 1 over 3x minus 1. And x cannot equal, all right, negative 4 for the x plus 4. And then the 3x minus 1 is a little bit harder, so all I need to do is I need to solve this. Where does that equal 0? Now, if I would have done my slide and divide, I'd already know that. But if you think about it for a second, with your slide and divide, what happened? Where does this 3 go? It would go under the 1, right? Okay. So my other 0 here is positive 1/3. Because if I wanted to, if this is my factor, 3x minus 1, in my slide and divide, it would have given me x minus 1/3, right? Because the 3 would have moved to in front of the x. So if I want the 0 then, I can just move the 3 back under the 1. Little method for helping it make some things a little bit easier. Okay. Number 8, multiplication. So when we're multiplying, what's the first thing we do? Okay, we're going to put them together, and when we put them together, though, we're also going to factor. Okay, so we're not going to actually do the multiplication. We're going to factor. Can I factor x minus 2? Okay, so I'll just write x minus 2. in parentheses. 4x minus 6. Do they have anything in common? Okay, they have a 2 in common. So I can take out the 2, and I have 2x minus 3. All right, now you can put the 2 in parentheses if you want, or you can just leave it between the parentheses. That's fine. Okay. In the denominator, can I do anything with the 2x minus 3? I can't, so I'll leave that as a factor. What about x squared minus 4? Can I factor that? Remember, that's the difference of two squares. X is squared and 4 is squared. So that's x plus 2 and x minus 2. So we cancel our like factors. Numerator and denominator both have an x minus 2. And they both have 2x minus 3. So my result, I have a 2 left in the numerator and x plus 2 in the denominator. And this one does not ask me for, it says assume they're all defined. So I don't need to say it's not equal to this and that. Okay, dividing is just like the multiplication, except for what? Okay, because I'm dividing by a fraction, the first thing I've got to do is copy, change, and flip. So I have to change it to a multiplication problem first. So I'm going to use parentheses to do that. So we have x plus 3, and I'm going to take this fraction here, and I'm going to put the x minus 1 now belongs in the numerator. And the x plus 3 is now in the denominator. Okay. So we copy, changed, and flipped. All right. So now instead of it being a division problem, it's a multiplication problem where we've put the numerator in the denominator and the denominator in the numerator. Now I can do any factoring that can happen. X plus 3 and x minus 1 in the numerator, they're all good. Okay. Nothing to factor there. So I'll just rewrite them. In the denominator, I've got x squared minus 2x plus 1. What do we get when we factor that? The factors, the one that add up to 2 are 1 and 1, right? So we've got x minus 1 twice, and then our x plus 3. Look for our common factors. Yep. X plus 3 in both the numerator and denominator, and x minus 1 in both the numerator and the denominator. And this is very key now that you remember that there are 1's that go here when that happens. So we don't forget, in the numerator I have 1 times 1, which is 1. And in the denominator we have x minus 1 times 1 times 1. To get x minus 1. Okay. All right, so all of this is just about factoring, okay, for the most part. Being able to factor and then to be able to cancel the like factors. Make sure that you don't ever start just crossing things out. Like a bad habit that some of you will do, okay, unfortunately, but I'm telling you, don't do this, okay? You cannot just cross those out. Right? There must be multiplication going on. There must be a factor to be able to do that. Okay? Those are not factors. Those are just being added to those things. So make sure you don't do that. It's illegal. Okay.
5 years.
All right, so there's a little bit of all that, and we have one last thing to look at then that was new today. Then. Oops, there it is right there. Okay, example 5. Solving some equations that involve rational expressions. So the first thing when you have an equation that has a rational expression, the first thing we want to look at is, can I factor anywhere? Okay, whether it's the numerator, the denominator, or possibly both. So in this case, in the numerator, we have x squared minus 25. So I can factor that. It's the difference of two squares. So in the numerator, I have x plus 5 and x minus 5 and over x minus 5 equals 14. So the nice thing about this is, and it's kind of like when we were doing the logarithms, if I had the logarithm of the same base on each side, just set those parts equal to each other. So here, I can cancel the x minus 5s. And then we're left with x plus 5 equals 14. So the nice thing about that is it simplifies to a very simple linear equation. So we subtract 5 from both sides, and we get 9. Now the big thing is here then, you must check your answers. You must check your answers. So when I check my answer here, I'm going to put 9 in for x. So 9 squared minus 25 over 9 minus 5, does it equal 14? Okay. And you could just do that right on your calculator to check it out. Let's see, 9 squared minus 25 is 56. And divide that by 4. 9 minus 5, I get 14. Okay? So it worked. I did it right. But you need to make sure you always check it. And I'm going to show you why with example with letter B here. Show you why that's important that you check it. Alright. So once again, we'll factor what we can. The numerator can be factored. Factors of negative 10 that add up to 3 are positive 5 and negative 2. So we can get rid of those x minus 2s. Once again then, we have this nice simple linear equation that when we subtract we get x equals 2. Now, here's why it's important to check your answer. Because if I check it now, I put 2 in for x, What happens in the denominator? Okay, we get 0. Can we divide by 0? No. Since we cannot divide by 0, that means then that our answer is what we call extraneous. Okay? That means it's a solution that I get, but when I put it back into the equation, it doesn't work. And so since that's my only result, and since 2 cannot work because of it being extraneous, what do I write down for my answer then? Not 0, and it's not undefined. No solution. Okay? All right, no solution. So my answer here is no solution. So it's very easy to check, okay, whether you're going to have that situation or not. Just look at your answer. If that number is going to cause the denominator to be 0, you know right away there's going to be no solution, okay? If your answer causes the denominator to be equal to 0, you know that it can't work, there's no solution there.
So